Okay, let's dive right in today. We're talking about something, well, fundamental to how things work, especially in science, but probably elsewhere too. Credit, recognition.
Right. Who gets it, who doesn't, and why?
Exactly. You know that feeling?
Yeah.
Sometimes it seems like the people who already have the big reputation, they just keep getting more credit.
hmm
Yeah.
Even for work that, involved a whole team or maybe wasn't solely their idea.
Yeah, it's like fame attracts more fame. And there's actually a name for that, isn't there?
There is. The sociologist Robert K. Merton called it the Matthew Effect back in 1968.
The Matthew effect. Okay, why Matthew?
Well, he pulled it from a pretty striking quote in the Bible, the Gospel of Matthew, chapter 13, verse 12.
Ah, okay, and how does that go?
It has two parts, actually. The first part is, "For whomsoever hath, to him shall be given, and he shall have more abundance."
Right. So the haves get more. That fits perfectly with the famous scientist getting even more recognition.
Exactly. That's what Merton initially focused on. It's that over-recognition. You see it with the halo effect. A big name gets attached, and suddenly the work seems more significant, or they get disproportionate credit.
It's not just luck, though, is it?
No, not at all. Merton talked about the accumulation of advantage. The source material we're digging into today points out that these well-known figures often had more than just brilliance.
Like what?
Well, charisma, for one. Holding powerful positions in universities or research centers, having, disciples or students who would naturally promote their work, it all builds on itself.
Creates a sort of feedback loop for fame.
Precisely. And Merton even observed that, functionally, less famous scientists were sometimes sort of advised to, let a bigger name publish their findings.
Really? Just to get the work out there.
Yeah, the idea being it was better for the science itself to be noticed, even if the credit wasn't quite right.
Hmm. That's
And here's a little irony the paper points out. The Gospel of Matthew itself probably wasn't actually written by the Apostle Matthew. Maybe not until generations later.
huh. So even the name has a layer of complex attribution.
Kind of fitting, isn't it?
It really is. Okay, so that's the first part of the verse. The haves get more. But you said there were two parts.
Yes. And the second part is crucial and maybe less discussed. It goes on. But whomsoever hath not, from him shall be taken away even that he hath.
Wow. Taken away even that he hath.
That's much harsher.
It is. And while Merton acknowledged this part too, it hasn't gotten nearly the same focus as the rich get richer side.
But this idea of the have-nots actually losing what little they have, that feels really relevant, especially when you look at history.
Incredibly relevant. And the research this paper draws on argues that this phenomenon is particularly pervasive when it comes to the historical contributions of women in science.
Ah. So it's not just being overlooked, it's having credit actively denied
I see.
or removed. Exactly. Scholarship over recent decades has just uncovered story after story of women scientists whose work was ignored, minimized, sometimes flat out appropriated, or just dropped from the standard histories.
We're talking about a systematic pattern here then, not just isolated incidents.
Yes, the paper argues it's a deep-seated bias in how credit gets assigned and how scientific history gets written and remembered.
Okay, if it's that systematic, it really does need its own name, doesn't it? To parallel the Matthew effect.
That's precisely the argument. And the paper proposes a name, the Matilda Effect.
The Matilda effect. Okay, who is Matilda?
She was Matilda J. Gage, an American suffragist, a feminist thinker, and you could argue an early sociologist of knowledge herself, writing back in the late 19th century.
Matilda J. Gage. And why her?
Well, it's incredibly fitting because Gage didn't just theorize about this kind of systemic bias and under-recognition. She experienced it herself. And she wrote about it. She articulated this pattern of women's contributions being diminished or claimed by men.
So she both lived it and called it out.
Exactly. So naming the effect after her does a couple of things. It highlights her work, which has often been overlooked.
Right, giving credit where it was maybe previously denied.
Precisely. And it captures that second part of the Matthew verse, the taking away from those who have not. It's about recognizing this pattern and pushing for a fuller and fairer history of science.
That makes a lot of sense. So the paper must give examples of this Matilda effect in action.
Oh, absolutely. Loads of them. And they show the different ways it can manifest. Sometimes it's about figures just being overshadowed.
Like who?
Well, the mathematician Mark Karok mentioned the physicist Marian Smoluchowski. Around the turn of the 20th century, he was doing groundbreaking work similar to Einstein's on things like Brownian motion.
Okay.
But by the late 20th century, Karok noted he was almost forgotten, completely eclipsed by the much more famous Einstein. His work was valid, important even, but history latched on to the bigger name.
So forgotten is one way. What else?
Sometimes it's more active, erasure, or distortion. The paper talks about Trotula of Salerno.
Trotula. Sounds medieval.
11th century. She was a famous physician, known for writings on women's health. We know she was real and respected her husband and son. Also physicians mentioned her.
Okay, so she was known then.
Very much so. But centuries later, things got weird. First, in the 12th century, her name got accidentally changed to a male name in a copied text.
Oh, wow.
And then much later, in the 20th century, a historian trying to sort of bolster the image of Salerno's male physicians basically argued she wasn't a physician at all, just a midwife.
Reducing your status.
Exactly. And the result? She was completely left out of the big authoritative Dictionary of Scientific Biography, the DSB, wiped from the standard reference.
That's incredible. Not just forgotten, but actively rewritten and removed.
It really is. Then you have cases of simultaneous discovery where credit just doesn't get shared equally.
Right. Two people find the same thing, but only one gets remembered.
Like Agnes Pockels. Late 19th century, no formal science education, but she did brilliant experiments on surface tension in her kitchen sink, basically.
Wow.
She wrote to Lord Rayleigh, a top physicist, explaining her findings. He was impressed, got them published for her in Nature, which is good.
Yeah. Sounds like he did the right thing.
He did, but historically, the fundamental work on surface tension is overwhelmingly credited to Rayleigh. Pockels is often just a footnote, if mentioned at all.
Okay. Another one.
Nettie Stevens. In 1905, she and the well-known biologist Edwin B. Wilson both, independently and at the same time, published work showing that chromosomes determine sex, X and Y chromosomes.
A huge discovery.
Monumental. But check the textbooks, check that same Dictionary of Scientific Biography. Wilson usually gets the lion's share of the credit, sometimes the sole credit. Stevens, who died relatively young, often gets minimized or omitted.
Same time, same discovery, different outcomes in the history books.
That's the pattern.
The paper also mentions collaborators, right? Particularly unmarried women working with male scientists.
Yes, and this is where you see some really stark examples, often involving major awards like the Nobel Prize.
Oof. Like who?
Take Frieda Robscheit-Robbins. She was pathologist George Whipple's associate for 30 years, co-authored nearly all their papers on treatments for anemia.
30 years is a long time.
It is. Whipple won the Nobel in 1934. He did acknowledge her importance and apparently shared some of the prize money with her and other female assistants.
What?
But she didn't share the prize itself, the actual scientific recognition at the highest level.
So some personal acknowledgement, maybe some money, but not the formal credit.
That seems to be the story. And then there's Rosalind Franklin.
Ah, the DNA story. That one's pretty well known now, isn't it?
It is, thankfully, though it took a long time. Her X-ray diffraction images were absolutely crucial for Watson and Crick to figure out the double helix structure.
Right. Photo 51.
Exactly. But she died before the Nobel was awarded in 1962 to Watson, Crick, and Wilkins. And the paper notes that even in their own later accounts, her contribution was often downplayed or minimized.
Died young, couldn't advocate for herself, and the story got shaped by others.
It seems that way. Another physicist, C.S. Wu. Her brilliant experiment in the 1950s proved that parity of fundamental symmetry wasn't conserved in certain interactions. It overturned a basic assumption in physics.
Sounds major.
Huge. The theorists who proposed it might not be conserved. T.D. Lee and C.N. Yang won the Nobel Prize for it pretty quickly.
And Wu, who did the definitive experiment?
Didn't share the prize.
Wow. Yeah.
The paper also mentions Jocelyn Bell, the astrophysicist who, as a graduate student, first detected pulsars, and Candace Pert, whose work was key to identifying opiate receptors in the brain.
And they didn't share in the subsequent big prizes either.
No, though the paper does note that these cases, Bell's and Pert's especially, became quite controversial later on, precisely because feminist critics raised questions about the lack of recognition.
So awareness grew over time, at least.
Yes, definitely. And perhaps one of the most sort of poignant examples is Lise Meitner.
Meitner, nuclear fission, right, with Otto Hahn.
Exactly. They worked together for decades in Berlin. She was a brilliant physicist. When they were bombarding uranium, it was Meitner, who had fled Nazi Germany and was communicating with Hahn from exile, who correctly interpreted Hahn's experimental results. She realized they'd achieved nuclear fission.
So she figured out what was actually happening.
Yes. She and her nephew, Otto Frisch, published the theoretical explanation, but the 1944 Nobel Prize for the discovery of fission went to Otto Hahn. Alone.
Alone, after decades of collaboration and her key insight.
Alone. The paper mentions Meitner was absolutely stunned. Hahn later wrote about it, sort of justifying it, saying the prize was for the chemistry, his specific work, and that Meitner had received other honors, like being named Woman of the Year in the U.S. after the war.
Which isn't quite the same as a Nobel Prize in physics or chemistry.
Not really. The paper calls this compensatory recognition, giving lesser awards or public fame instead of the core scientific prize. And Meitner also lost credit for something called the Auger effect, which she observed first but was named after Pierre Auger, who published later.
Man, that's rough. And this happens with married collaborators, too.
The paper suggests it might be even more common there, perhaps because the lines get blurred or assumptions are made.
Like who?
Hertha Ayrton, a British physicist and engineer, she worked closely with her husband, W.E. Ayrton. When he got ill, she apparently carried on his research and even published some of it under his name.
Under his name. Why?
The source suggests it was to protect his reputation and standing.
Wow. Sacrificing her own credit.
Seems so. Then there are Gertie and Carl Corey. They actually did share the Nobel Prize in 1947 for their work on metabolism.
Okay, so that's a positive example.
It is definitely a landmark. But the paper notes there were persistent rumors at the time and since that Gertie might have actually been the more brilliant or leading scientist of the two. Hard to prove definitively now, of course.
But the rumor itself is telling.
It is. And consider Ruth Hubbard. She did significant independent work on the biochemistry of vision. Later, she married George Wald, who also worked in that area. When Wald won the Nobel in 1967...
Let me guess. Her earlier independent work got folded into his narrative.
Pretty much. Retrospectively, it started being attributed mainly to Wald or described only as their later joint work, diminishing her initial separate contributions.
Oh.
One more striking Nobel case. Isabella Karl, a renowned crystallographer, she worked alongside her husband, Jerome Karl, for nearly 50 years, developing methods crucial for determining molecular structures.
Oh.
In 1985, Jerome shared the Nobel Prize in chemistry for that work. Isabella, despite her parallel and essential contributions, was omitted.
Seriously, after 50 years of working together.
Yes, and it caused quite a stir. Their daughter, also a scientist, publicly protested the decision, calling it unjust.
Good for her.
Yeah.
So, okay, these individual stories are powerful, really powerful. But the paper argues this isn't just anecdotes, right? It's systemic.
Exactly. The Matilda effect isn't just about individual tragedies. It shows up in broader patterns, in aggregate data, and how scientific institutions presented themselves.
Oh, so?
Well, look at scientific directories. The foundational biographical dictionary in the U.S., started in 1906, was called American Men of Science.
Men of Science. Okay, pretty blatant.
Right, even though from the start it included hundreds and later thousands of women scientists. But the name itself minimized their presence, framed science as male. And they didn't change that name until 1971.
70 years later.
Yep. And other more selective publications like McGraw-Hill's Modern Men of Science, or that Dictionary of Scientific Biography we keep mentioning, had incredibly few entries for women, reinforcing that skewed picture.
So the very tools used to record scientific achievement were biased.
It seems so. And this bias also crept into social science studies about scientists.
How did that happen?
There's a fascinating example. Anne Rowe's 1953 book, The Making of a Scientist. It was hugely influential, but she deliberately excluded women and scientists of color and others from her main sample to get a pure sample of what she considered the most eminent researchers who happened to be white men. But then the book presented this group as representative of the scientist. Rowe herself later admitted this reflected the sexism of the male scientists she studied.
So the study replicated the bias it was studying.
Kind of, yeah. Another study, Origins of American Scientists from 1952, actually had data on women in its tables.
Okay.
But the authors completely left women out of the written analysis, the main text. So they failed to identify highly productive women's colleges as significant sources of future scientists because they only discussed the men's data.
Just ignored the data they had?
It's like it. And one more. The Professional Scientist in 1962, they interviewed women scientists, but then just didn't include them in the final book, which focused only on white men.
Why would they do that?
The paper speculates maybe the women's experiences or perspectives didn't fit the neat narrative the researchers wanted to create about the typical professional scientist.
So across-the-board directories, studies women's presence and contributions were systematically downplayed or just erased.
That's the argument. It wasn't necessarily always conscious malice, perhaps, but the effect was a constant reinforcement of under-recognition.
It makes you wonder how many contributions we just don't know about.
Exactly. And the paper points to a really useful framework for understanding the ways this happens, actually borrowed from literary criticism.
Oh,
Joanna Russ's book, How to Suppress Women's Writing. Russ outlines all these recurring tactics used to dismiss or diminish creative work by women.
what kind of tactics?
Things like denial, she didn't really write it. Contamination, she wrote it, but look what she wrote about, it's trivial. Lack of authenticity, she wrote it, but she's not really a major figure. Or isolation, she wrote it, but she's just a freakish anomaly. That kind of thing.
The she wrote it BUT
Mhm.
pattern.
Exactly. It's a whole repertoire of dismissal. And the paper argues this framework applies just as well to understanding how women's scientific contributions have been suppressed or minimized. It helps categorize the Matilda effect.
That's a really helpful way to think about it. Okay, so let's go back to the name itself, the Matilda Effect. You said Matilda J. Gage was the namesake. The paper considered others.
Briefly, yeah. Maybe Lise Meitner, given her story, or Harriet Zuckerman, who did a lot of the foundational research for Merton's original Matthew Effect paper, something Merton himself later acknowledged.
Ah, interesting. An effect within an effect.
Kind of. Or even biblical figures. But the paper strongly argues Gage is the most fitting choice.
So tell us a bit more about her. Why is she the perfect namesake?
Well, she was born in upstate New York, 1826. Her father was a doctor and abolitionist and believed in women's rights, which really shaped her. She didn't have much formal schooling, but was clearly brilliant, became a powerful speaker and a leader in the women's suffrage movement.
And she wrote specifically about women, inventors, and credit.
Absolutely. Her 1870 book, Woman as Inventor, tackled this head-on. She even argued that Eli Whitney didn't invent the cotton gin alone, that he got crucial ideas or instructions from a woman, Catherine Littlefield Greene.
Wow. Challenging a foundational American invention story back then.
Yes. And she co-edited The Massive History of the Women's Suffrage with Susan B. Anthony and Elizabeth Cady Stanton.
Okay, so clearly focused on women's history and rights. What about the connection to the Matthew, quote, the sort of religious or systemic critique?
That's key. Her later work became very critical of organized religion's role in suppressing women. Her 1893 book, Woman, Church, and State, is a powerful argument that Christianity, historically, had justified exploiting women, taking their contributions intellectual, social, economic, while denying them power and credit.
So she saw religion as part of the mechanism of holding this,
Well,
taking away.
very much so. She argued it provided the rationale for women's subjugation. She was also involved in creating the Woman's Bible, which reinterpreted scripture from a feminist perspective.
So even though she didn't specifically analyze Matthew 13.12,
Right, she didn't write about that specific verse, as far as we know. But she fundamentally understood and denounced the underlying pattern. Men benefiting from women's labor and ideas, while women were systematically denied recognition and reward. She saw it as central to patriarchal power.
and she herself was overlooked later.
Yeah, the paper uses a quote from the feminist writer Dale Spender, who said Gage herself was ultimately negated and denied, kind of written out of the mainstream suffrage history compared to Anthony or Stanton. So she embodies the very phenomenon the effect described.
Wow, that makes perfect sense then. She lived it, she named the dynamic, and then she kind of suffered from it historically.
Exactly, it brings it full circle.
Okay, so let's try and wrap this up. We have these two interconnected concepts.
Right. On one side, the Matthew effect. The already famous and recognized tend to get even more recognition, accumulating advantage. To him that hath shall be given.
And on the other side, the proposed Matilda effect, named for Matilda J. Gage. The systematic tendency for contributions, especially those by women, to be underrecognized, ignored, denied, or actively taken away. From him that hath not shall be taken away even that he hath.
It's highlighting that second, often neglected part of the equation. It argues this isn't just random noise. It's a persistent, pervasive bias throughout history, particularly visible in science.
And naming it, calling it the Matilda effect, is important.
Crucial, the paper argues. It forces us to acknowledge the pattern, to look for it, and ultimately to try and write a more complete, more equitable history and sociology of science, one that recognizes all the contributions, including those of the many Matildas who've been historically marginalized.
A history that includes everyone who was actually involved.
That's the goal.
So here's a final thought for you, listening to this deep dive. We've heard about the Matilda effect playing out over centuries, particularly in science. Where might you be seeing similar patterns today?
Yeah, think about it. In research labs, in university departments, in tech companies, maybe even in artistic collaborations or community projects. Where might credit be flowing unevenly, or where might certain voices or contributions be getting subtly or not so subtly minimized or overlooked?
How does knowing about the Matilda effect change how you look at who gets celebrated and who might be missing from the picture? Something to definitely reflect on.